Hello students, this is Shweta Patil and I welcome you all to the video lecture on computer organization. In the previous video, I discussed about memory system considerations. In this video, I will be discussing about read-only memories. So, we discussed in the prior videos about static RAM and dynamic RAMs. So, these both static and dynamic RAMs are volatile in nature and they lose the information whenever the power is turned off. So, not in all the applications we can make use of this type of volatile memories. Many applications require non-volatile type of memory where the information will be stored even if the power is turned off. OS softwares need such non-volatile type of memories, and in different embedded systems we'll be making use of non-volatile types of memories. One of the such memory which is non-volatile in nature is ROM, that is read-only memory. Okay, so you can see in the figure, in this figure you can see this is a cell which is representing the ROM cell, one cell in read-only memory it is. It's having a bit line and a word line. To this word and bit lines, a transistor is connected with a fuse, isn't it? So, logic 0, to get logic 0, what is to be done? Transistor is connected to the ground point. Fuse will be closed. Okay, how it is done? The fuse P is closed. When I close this P, transistor is directly connected to the ground through P. Thus, whatever is available on the bit line will be grounded. That's why the logic level is taken as 0, isn't it? Then logic 1 level will be taken when the transistor is open, means the fuse is open, the transistor will not be connected to the ground. That's why whatever the bit line is will be taken as 1. So logic level 1, isn't it? Then to read the state of the cell, what we have to do? The word line has to be activated, and sense circuit at the end of the bit line will generate the proper output value. This is how 1 and 0s are stored in ROMs. Okay, we are having different types of ROMs. You can look at in the slide. We have different types of ROMs as PROM, EPROM, EEPROM, flash memory. PROM indicates programmable ROM, EPROM indicates erasable programmable ROM, EEPROM indicates electrically erasable programmable ROM, and the other is flash memory. Let's discuss about these. Moving to the first type called as PROM. So, PROM. The data is loaded by the user here. What PROM allows? It allows the data to be loaded by the user. So, programmability can be done. Means I can program the cell by making use of a fuse. I can insert a fuse at point P. You have looked at the fuse in the diagram when shown here, isn't it? This is the fuse. P is the fuse, right? At point P, if I insert a fuse, by inserting a fuse at point P in the ROM cell, I can program it. Okay, now programming is done. So before programming, that is initially, all the contents of the cells will be 0. So I can insert 1 within some of the cells where all I need. I can insert 1 where all I need. There all I am inserting ones. How? By burning the fuses using high current pulse, because when 1 will be stored in the cell, when fuse is not connected to the ground. If T is not connected to the ground, how T cannot be connected to the ground? T cannot be connected to the ground if the fuse is off, if it is not connected, if it is not on, means if it is not connected, if fuse is off, if it is burnt, transistor will not be connected to the ground. That's how the content of the bit will be taken as 1. This is an irreversible process because we have burned the fuse and we can't again insert one more fuse. That's why it is only programmable, it's not erasable. Only once it is programmable, and that is done by the user. Some of the advantages which can be seen for PROM is it provides flexibility, it is faster, it is less expensive because programming can be done by user directly. Okay. Then moving to the second type called as EPROM. What is EPROM? Erasable programmable ROM. You can see in the prior case it was only programmable, but now it is erasable. The content can be erased and then a new content can be loaded in. So this can be done by making use of special transistor. Okay. A connection to the ground is always made at P and a special transistor will be used. The transistor has the ability to function. How it is functioning? It can function as a normal transistor or a disabled transistor that is always turned off. In two ways it can work out. Transistor can be programmed to have permanently open switch. How we can do this? By injecting charge into the transistor, I can make it act as a permanently open switch, or erasing of the contents of the transistors can be done, okay, by exposing the chip to the ultraviolet light. So where all I need to delete the contents, there that cells can be exposed to ultraviolet light and erasing will be done. Okay, it again is having its own advantages and disadvantages. It provides flexibility during the development phase. It is capable of retaining the stored information for a longer time. The disadvantage is the chip must be physically removed from the circuit for reprogramming. This is much more complex, isn't it? The chip has to be removed and then it has to be inserted back. The entire content needs to be erased by UV light. Then it can be reprogrammed. Okay. Then EEPROM. EEPROM is electrically erasable. In EPROM, what happened? Erasing will be done by using UV rays, isn't it? But one more step ahead they moved, that is erasing is done electrically. That's why the name is electrically erasable PROMs. Okay. So electrically erasable PROMs, wherein programming is done erased and then it can be reprogrammed. It allows the erasing of all the contents of all cells contents selectively. It's not that all the content of the memory will be deleted. No, selective content can be removed, it can be erased. One of the disadvantages, it requires different voltage for erasing, writing, reading the stored data. Okay. Next is about flash memory. The last type of memory is flash memory. What it does, it reads the contents of a single cell and write entire content of a block. It reads a single cell and it can write the entire content of block, means a single cell cannot be written. Writing has to be done in terms of blocks, right? Before writing, the previous content of the blocks will be erased. In order to write the new thing, the previous content has to be erased. One of the advantages is flash drives have greater density, which leads to higher capacity and lower cost per bit. It requires a single power supply voltage and consumption of power supply is also less. We can have flash memory in two methods. We can implement this flash memory into two methods. One is flash cards and other is flash drives. Then what these flash cards and drives are? One of the way to construct a larger module is to mount the flash chips on the small cards. Such flash cards have standard interface. The card is simply plugged into a accessible slot. Okay. 1 minute of music can be stored in 1 megabyte of memory. Okay. Hence, flash cards can store an hour of music. Next is about flash drives. Flash drives, larger flash memory can be developed by replacing the hard disk drive. These are designed to fully emulate the hard disk. These are the solid state electronic devices that have no movable parts. Okay. So they have shorter seek and access time, that is one of the advantage. Low power consumption is one more advantage, and insensitivity to vibration. These all are the advantages of the flash memory. Disadvantage is the flash drive, the capacity is less than that of the hard disk. More cost will be there. Flash memory will weaken after it has been written a number of times. All these are the disadvantages of flash memory. So this is all about ROM, that is read only memory. Thank you.